Hello everyone. Let's study about the variation of intensity in fringe pattern, that is in Young's double slit experiment. To understand this, let's recall Young's experiment where we had a screen and then there were two slits, and in front of the slits the source was placed. Then what was seen is the center of the screen would be a bright band, then a dark band, and then a bright band. So you get alternate dark and then bright bands. But here the diagram drawn is not exactly showing what the pattern would be. That is, in case of Young's experiment, we don't get a bright band which is fully bright and a dark which is fully dark. We don't get that way. Rather, what we get here is a pattern where it is something of this form. That is, the center of the band is completely bright, and when we move away from center, the brightness will decrease. So if this is the center of the center bright band, if we move in either direction, the intensity will decrease. At some point it becomes completely dark. This is center of the dark band. Again, when we go away from here, the intensity will increase. So this whole thing is not the bright band. Rather, you can take that this part would be the bright band and this is the dark band. This is the bright, this is dark. So as seen here, there is no clear-cut division. It is not a pattern. It is not like completely bright and completely dark. It isn't that way. The intensity gradually changes. If this is the bright band, then the center of this will have maximum intensity, and when we go away from it, it will decrease. So center of the dark band will have the least intensity as given here. This is the least intensity or zero intensity. The diagram is what is shown here. A diagram is not of this type. This is not what you get. I just kept it here to show how diagrams are varying, but it's not like this. We don't get blocks here. Rather, they get a gradual change in intensity. If we plot a graph of intensity versus the wavelength or the path difference, then recall that for a bright band, the path difference is equal to n lambda, where n is equal to 0, plus or minus 1, plus or minus 2, etc. And for dark band, it is 2n minus 1 lambda by 2. Again, n is equal to plus or minus 1, plus or minus 2, etc. This is for bright band, this is for dark band. So the graph is plotted for intensity versus the path difference. We get a graph like here. Observe carefully that each bright band has the same peak. The peak is same for all the bright bands, which means the center of all the bright bands will have same intensity, and then when we go away from it, it will start to decrease. So this point here indicates center of the dark band. So when you put n is equal to 1, this becomes lambda by 2. So lambda by 2 is the first dark band. When you put n is 1 here, becomes n1 lambda, and here it is lambda. So these centers correspond to multiple of lambda. So this corresponds to 1 lambda, 2 lambda, and 3 lambda, and this corresponds to half of the lambda multiple. So this would be lambda by 2, this would be 3 lambda by 2, this is 5 lambda by 2. And here also it will be, the value will be 1 lambda, 2 lambda, 3 lambda, but in other direction, which means it is on the other side of the central bright band. This is what we get in case of interference. And also keep in mind here that there's a gradual decrease, not a sudden decrease. Now suppose imagine that the pattern was just like this. It is completely bright and then dark completely and again completely bright. In that case, the pattern would have been like this. This indicates complete bright, complete darkness, and again complete bright. This is what we have got. But what is seen here is a gradual decrease. So it goes from brightness to gradual decreasing and becomes zero, that is, it becomes darkness and gradually increases. So this is the pattern for intensity. In terms of equation, what we get is, we know that intensity is given as root I1, or rather intensity at any point is given as I1 plus I2 plus 2 root I1 root I2 into cos phi. In case of Young's experiment, I1 and I2 are equal. Let's call this as some point I. So intensity at any point I is equal to I1 plus I2 plus 2 root I1 root I2 cos phi. Let's call intensity at any point P as IP, and let I1 is equal to I2 is equal to some I. Therefore, intensity at point P is equal to I plus 2 into I into cos phi, that is 2I, plus it becomes 2I. Root I into root I would be just I into cos phi. From here, if we pull out 2I common, then what remains is, it is 1 plus cos phi, that is intensity at any point is equal to 2I into 1 plus cos phi. Now recall that cos 2 theta is equal to 2 cos square theta minus 1. Using half angle, we can say cos theta is equal to 2 cos square of theta by 2 minus 1. We're putting half angle here. Now from this, bring 1 this side, then cos square theta by 2 is equal to 1 plus cos theta, or there is 2 here, it's 1 plus cos theta. So pull back here, I used the term theta by this phi. Therefore IP is equal to 2I, it's 1 plus cos phi, should be 2 times cos square phi by 2. Therefore intensity at any point is equal to 4I cos square phi by 2. So we can find out at which point we get dark and bright band by using a relationship that phase difference, which is called as phi in this case, phase difference is equal to 2 pi by lambda into path difference. So you know what is the path difference for bright and dark bands. Putting it back here, we can tell at which point it is bright and dark, and also here the value of phi would vary. The value of cos phi also would vary from -1 to +1. So the intensity would not be just a constant, it varies on phi. That's the reason that we get a pattern of this kind also. This is what is cos phi proportional to.